Okay, this is 2.6 notes. This is the basic functions of graphs, covering different concepts such as the basic shapes of common graphs, also continuity or discontinuity, and whether a function is increasing or decreasing. So I'm going to speed up my writing on this. You can pause the video at any time. That way you can make sure you're taking the notes over it and write down everything that I'm writing down. I'll pause it right here. So the very first function that we need to cover is called the identity function. It's called identity is itself. Whatever y equals, x equals. Whatever x equals, y equals. Notice on the graph, it's right one, up one, or you could go back one, down one. That continues. Right 5, up 5. Okay, it's the line y equals x. You should have had that before. Domain, negative infinity to positive infinity. Range, negative infinity to positive infinity. So there's nothing new there. The idea of continuity basically means, can I draw that graph? Can I draw that graph without raising my pencil or without raising my pen? In our notes today, we don't have any graphs that are discontinuous, but we'll talk about that on Friday. Also, when we do increasing or decreasing, we always go from left to right. So we always look at a graph from left to right. From left to right, we are always increasing on the identity function. Okay, next slide. Again, if you need to pause the video to finish up taking notes, pause the video, take your notes. So we have even functions. Even functions are x squared, x to the fourth, x to the sixth, x to an even number, right? Odd functions. These are going to be x to the third, x to the fifth, x to the seventh, something with an odd number, right? Here's the basic shape of even functions. There's a little bit of differences. Okay, the main difference that I want to point out is they all go to a vertex point of 0, 0. Okay, because it's just x squared, it's just x to the fourth, just x to the sixth. It goes to the vertex or the origin of 0, 0. The difference between x to the sixth and x squared, the x to the sixth function rises faster, right? As we go to the left and go to the right, it gets closer and closer to positive infinity faster. It also, real close to the point 0, 0, flattens out a little bit. So notice x squared is a little bit more pointy, x to the sixth is a little bit flatter. Okay? All of these functions start high and finish high. Even functions start high and finish high from left to right. There's the information about x to the sixth is wider, x to the sixth is skinnier. Okay? More pointy or flatter when turning. Okay. If the leading coefficient, LC is the leading coefficient, if it's negative, then it's going to open down. All of my examples are positive, they all open up. But if it's negative, it opens down. Also, to look at whether it's increasing or decreasing, we'll do that more later. Okay, odd functions kind of go like this. Start looking for the differences between x cubed and x to the seventh. Okay, start looking for the differences between x cubed and x to the seventh. Because all the leading coefficients are positive, they go from low to high when moving from right to left. From low to high, moving from right to left. Okay? As the exponents increase, the functions rise faster. Okay, if the leading coefficient was negative, it'd go from high on the left to low on the right. Okay, something else to look at on the even functions. When you move left to right, and you're talking about increasing or decreasing, when we move left to right, on the even functions, it's decreasing from negative infinity to 0, and then increasing from 0 to infinity. On the odd functions, increasing from negative infinity to positive infinity. Okay, so here's a little bit more about y equal x squared, and I'm going to talk through the increasing, decreasing again. It is continuous also. We can draw the graph without raising our pencil. There we go. It's decreasing from negative infinity to 0, increasing from 0 to infinity. Make sure you're putting the brackets around the zeros because it does include that point. The point 0, 0 is a vertex, also the turning point. Okay, if it's negative x squared, it's upside down. Okay, if it's upside down, it increases from negative infinity to 0, decreases from 0 to positive infinity. Change it up a little bit. What's the 2 do to x squared? It just makes it rise faster. Okay, again, at any time, stop the video, take the notes. Okay, the purple graph, y equal 2 to the x squared, see how it rises faster than y equal x squared. It's still kind of pointed at the vertex. X to the 6th versus x squared, x to the 6th rises faster, but look around the vertex, x to the 6th is wider. Okay, continuous and increasing and decreasing, all the same for those. Y equal x to the 3rd, this is the odd function, continuous, increases from negative infinity to positive infinity. Okay, negative x to the 5th, so this is a negative odd function. What's it do? It turns it upside down. Okay, notice here, see when it crossed the line y equal x, the higher the exponent, the flatter it is as it crosses. Okay, this is continuous also. It decreases from negative infinity to positive infinity. So notice why, notice the differences. Okay, new function. This is one of the basic functions, absolute value function. Okay, y equal absolute value x. Okay, looks just like a line going up and to the right. However, it also goes up and to the left because it cannot be negative. It's a V shape. So anytime you see a V shape, absolute value function. This is continuous. Could I draw it from left to right without raising my pen? I could. Okay, it's decreasing from negative infinity to 0, and then it's increasing from 0 to infinity. We always do decreasing and increasing from left to right. What happens if we put a negative in front? Well, it turns it upside down. On absolute value, if you put a negative on the inside, it does not change anything as far as the way that the function looks. Okay, so there's absolute value function. Notice the vertex, 0, 0. Okay, make sure that you stop the video to take your notes. Next function is called the square root function. Okay, y equals square root of x. Okay, or we could have even roots like y equals 4th root of x, y equals 6th root of x. Okay, y equal square root of x looks kind of like a parabola on the side, but only half of it, because otherwise it wouldn't pass the vertical line test. Okay, y equal 4th root of x. Same thing, except that it moves to the right faster, right? So it doesn't rise as fast. Both of these are continuous. Both of these are increasing from 0 to infinity. We want to talk about domain from 0 to infinity. Range from 0 to infinity. If we put a negative out front on these, okay, negative out front, it flips it across the x-axis. Okay, if we put the negative on the inside, it flips it across the y-axis. That's a very important tool to remember, where the negatives go, how it affects the graph. So make sure you're paying attention to that. Okay, this is the last slide. We have odd root functions. Okay, y equal cube root of x, y equal fifth root of x. Okay, y equal cube root of x, y equal fifth root of x. Y equal cube root of x in red, or in black, y equal fifth root of x in red. Both continuous. Both of these are increasing from negative infinity to positive infinity. What happens if we put a negative out front? Well, the negative out front makes it reflect across the x-axis. Okay, it looks just like that. If we put a negative on the inside, it would also make it reflect across the y-axis, and it would actually look the same. Okay, so hopefully that addresses the idea of the basic shapes. It addresses the concept of continuous versus discontinuous, and it addresses the concept of increasing versus decreasing. Okay, once you have these notes copied down, make sure that you are starting the lesson 2.6 homework, and I'll finish the notes for piecewise functions on Friday.